Welcome to this lesson on completing the square. This is one of the most important algebra skills in GCSE Higher Maths, and although it can look difficult at first, the method is actually very structured once you see what's happening. In this lesson we'll go step by step, starting with the idea behind the method, then working through examples carefully and finally look at why this form is used. Let's begin with a quadratic expression like this, x squared plus 6x plus 5. This is the normal form that most students are used to seeing. But sometimes instead of leaving a quadratic like this, we want to write it in a different form, one that reveals more structure. We want to rewrite the quadratic in a form like this, a square plus or minus a number. This is called the completed square form. The reason that it's useful is that it tells us much more clearly what the quadratic is doing. But before we talk about that, we need to understand how to create it. The first step is to focus on just the x squared term and the x term. So for the moment, I'm only going to look at the x squared plus 6. Now I ask, what square bracket would expand to begin like this? If I try x plus 3 all squared and expand it, I get x squared plus 6x plus 9. This is very close to what I want. The x squared plus the 6x are correct, but we have an extra 9. The original expression only had plus 5, not plus 9, so I need to correct that. To get from plus 9 down to plus 5, I need to subtract 4. That's why x squared plus 6x plus 5 becomes x plus 3 all squared minus 4. This is completing the square. Now let's make the method faster. Why did I choose 3? Because when the coefficient of x is 6, I take half of it. Half of 6 is 3. That gives me the number that's going to go inside the bracket. So, with x squared plus 6x, I write x plus 3 all squared. In general, if you have x squared plus bx, the bracket begins as x plus b over 2 all squared. At GCSE though, the safest approach is to not memorise the formula immediately. Instead, understand the pattern and take half of the x coefficient. Let's do another example. This time we'll complete the square for x squared plus 8x plus 3. Half of 8 is 4, so the bracket will be x plus 4 all squared. Now I check the expansion. X plus 4 all squared gives x squared plus 8x plus 16, but the original expression only had plus 3, so I need to subtract 13. That gives me the completed square form, x plus 4 all squared minus 13. Now let's do one with a negative x term, because that's where many students make a mistake. We've got x squared minus 10x plus 7. Well, half of minus 10 is minus 5, so I'll begin with x minus 5 all squared. When I expand that, I get x squared minus 10x plus 25, but the original expression had plus 7, so I need to subtract 18. That gives x minus 5 all squared minus 18. So why do we bother doing this? Because the completed square form tells us something important immediately. If y equals x plus 3 all squared minus 4, then the graph reaches its minimum when x plus 3 equals 0. That happens when x is negative 3. And the minimum value of y is negative 4, so the turning point is negative 3, negative 4. This is much harder to see from the original quadratic form. Now let's do a harder example. This is going to be harder because the coefficient of x squared is no longer 1. First of all, we're going to need to factor the 2 out from the x squared plus 8x. That gives 2 lots of x squared plus 4x plus 1. Now inside the bracket, I complete the square. X squared plus 4x becomes x plus 2 all squared minus 4. Then I'm going to multiply the whole bracket by 2. That gives 2 times x plus 2 all squared minus 8 plus 1. And finally minus 8 plus 1 gives minus 7. So the completed square form is 2 times x plus 2 all squared minus 7. Here's a little exam tip. If the x squared coefficient is 1, complete the square directly as we've done in this video. If not, factor it out first and then complete the square.